Good morning, class. So today we are going to begin with the question of the day like we usually do, but this question might seem a little bit odd to you, so let's explain. The question states, how big is our island? And so the key that you need to figure out this question is by reading the comic by Stuart McMillan called St. Matthew Island. You can find it in your Schoology in your chapter 5 folder. Okay, and so it is important that you pause the video right now, go find it, read it, come back, and we'll talk about it. Thanks. And we're back. So let's look at St. Matthew Island a little bit here. I am going to the last page of the comic, and it says here, the island's untapped natural resources became the reindeer's source of prosperity and also the seeds of their demise. The island was only so big, its resources only so many. How big is our island? So, we see the picture of the actual island here. But as you can see, it looks like we're zooming out further and further until we get a view of our whole entire Earth. So the question is, how big is our island? And what you guys are supposed to answer to this question is the Earth. So we have to think about the St. Matthew's Island as maybe a symbol for the entire Earth. So today we are going to be continuing to refer to the island and what happened to the reindeer on the island. So it's important that we keep remembering what happened, but this is also a it's a making us think comic about how we have just so many resources on our planet Earth and how eventually we might run out. Okay, so let's go into our PowerPoint. You guys will have a note guide for this PowerPoint. It is the population growth PowerPoint that I'm going to be going through. You guys will be following along with me and filling out your note guide for population growth. So our key question today is, how do ecologists study population growth? Okay, so we are going to start here with our first slide. How do ecologists study population growth? Okay, so we have 4 things that ecologists look at, and we're going to be the ecologists today. So the first thing we have to look at is the geographic range of the population we're studying. We also have to look at the density and distribution. Third, we look at the growth rate. And fourth, we must examine the age structure. Okay, so make sure you wrote down those 4 different categories for how ecologists study population growth. So our next page is talking about geographic range. This is the area inhabited by a population. So when we're talking about an area, think of the location that this animal or this species, because it could be plant that has a geographic range, the location that it occurs, okay? So a population's range can vary enormously in size depending on the species. So we had our example of the reindeer, and you can see what's highlighted in red here. That is the reindeer's geographic range. Now, when we were reading the comic about St. Matthew Island, what was that geographic range? Even though reindeer can exist in all of these locations that are in red, the reindeer what we were talking about in St. Matthew Island, for their geographic range, we would consider it only St. Matthew Island because that's all that we were looking at. That's all that we were getting the numbers for, was for that specific geographic range. So ecologists can narrow down the geographic range depending on what they're looking for. We also have examples of whales, right? Whales migrate back and forth throughout the oceans. So they're going to have a very large geographic range. So that's where this very enormously in size. And then we could also have teeny tiny bacteria. And the example that I thought of is that the geographic range for bacteria could be the rotting pumpkin in my backyard, right? So bacteria is so tiny that we can make their geographic range also so tiny that that's the location that they're located, and that is the all that we're studying, okay? So the ecologists do have the ability to define the geographic range, and that's important for our next way that we study population growth with density and distribution. So with population density, it's the numbers of individuals per unit area. So when we define the geographic range, we are going to get the unit area that we need to define population density. Populations of different species have very different densities, even within the same environment. So I want you guys to think of if we were studying a pond down the road and we wanted to study the ducks there, right? So we could be maybe seeing about 10 to 100 ducks that frequent that pond. But if we were looking at the pond's population density overall for different species, we would get numbers in the hundreds of thousands if we were looking at something tiny and microscopic like bacteria, other protists that could be within the water there. So even though we're looking at the same geographic range, the same area, we could have a big variation in the density of species occurring there. Also, then we have population distribution. So this refers to how individuals in a population are spaced out. And so we are going to talk about these three distributions. Uniform, which I think the picture is kind of funny because it does look like those penguins are kind of clumped together. But if you ever watch like Planet Earth and you see the big panoramic views of Antarctica where the penguins live, you'll see that they're generally spaced out pretty good. Now that doesn't mean that they don't huddle together every so often for warmth, but there is nothing keeping them clumped there. We also have random distribution. So this occurs a lot of times with plants. We see our dandelions in the picture and we see this distribution here that there's like 4 clumped here, then 2, then 1, and that's probably because of a result of the seed dispersion method that dandelions use. We also see then a clump distribution method over here, and that, if you're looking at the picture, those are elephants, okay? And so what we know about elephants is that they live in dry places. So they're going to clump around the resources they need, like water, to survive. So that's why we see a clump distribution specifically with elephants, but that's also why we sometimes see clump distributions of other types of animals. So that's something to keep. So moving on to our third way to describe a population is by describing the growth rate. And the growth rate determines whether a population size is increasing, decreasing, or staying the same. So when we see that a growth rate is 0, do you think that that would mean that the population size is increasing, decreasing, or staying the same? If you said staying the same, you are correct. So growth rate equal to 0 means staying the same, and you guys can write that down right there on the line, the blue line. What about if the growth rate is greater than 0? What do you think it means if the growth rate is greater than 0? Would the population size increase, decrease, or stay the same? If you said it will increase, you are correct. So A growth rate greater than 0 means it's increasing. And then what about a growth rate less than 0? Increasing, decreasing, or staying the same? If you said decreasing, you are also correct. And we will see the answers pop up right there. And so think about if we have our bacterial population in this picture, that bacteria grow at a pretty fast rate. So we would expect to see a bacterial population growing, so a number greater than 0. But think about if we started taking antibiotics. That population would start decreasing. The population size would start decreasing and the growth rate would become less than 0. Our last and fourth way to describe a population is by age structure. So age structure, when we look at age structure graphs, they are separated by the number of males and females of each age. So age structure, even though it includes the word age, which makes sense, it also usually includes a splitting of males and females, because we need to understand how many males and females live in a population to assess reproduction. And recall that reproduction can only happen when plants and animals reach a certain age. So I really like looking at these graphs because they are color coded. We have our age 0 to 14 being blue. We have our age 15 to 44, so our reproductive ages here in yellow, and then our orange ages 45 to 85 typically are not reproducing anymore. So we can see that there is rapid growth happening in these different countries like Guatemala, Nigeria, Saudi Arabia. We see a slow growth, so we still see this triangular pattern that we have more children here on the bottom, and as we go up we get less and less just because there's more and more chances that people are going to die as people get older. In Spain and Austria and Greece, right here, we see that there is 0 growth because it has more of a rectangular shape, if you guys can see that. And then we have negative growth actually in Germany, Bulgaria, and Sweden as of right now. And that is because there is a smaller amount of children in blue down at the bottom. Okay, so that is what accounts for negative growth, just like how we were talking about the growth rate on the other slide. So we were talking about population growth, and there are 4 factors that affect the population size. Birth rate is one, death rate is the second one, third one is immigration rate, and the fourth one is emigration rate. So birth rate versus death rate. Stick with me because this is a very repetitive thing, but it's important to see the pattern. A population will grow when birth rate is higher than death rate. A population will shrink when birth rate is lower than death rate. And a population will stay the same when birth rate equals death rate. So make sure you guys get that written down in your note guide. We are going to skip past this YouTube video. It's a really cool video, but we're just not going to have to watch it right now. We got to move forward into immigration versus emigration. Make sure though you go back and watch that video on your own later. So immigration is when a population will grow if individuals move into the range from elsewhere. So the way to remember the difference is immigration begins with an I, so think about moving in to a place, but emigration begins with an E, and it's when a population will decrease if individuals move out of the population's range. So think about emigrate means to exit a place. So you emigrate from your home country. So you're exiting or leaving, while you immigrate to another country. Okay, so those are keys to help us remember the difference between emigration and immigration. And then we have our last slide here with the fish. I want you guys to look at these different scenarios and label what is happening when a population increases when new individuals are born? We need to see how that impacts our fish population. I would also like to see